Hi everyone, welcome to this video. So this video I'm going to talk about some basics of networking. Now that's just a disclaimer, I am no expert. I myself am just learning this purely for the sake of necessity, because some situations in my work, my projects kind of need me to understand a little bit of what networking is about. So what is networking? Well, if you heard of the term IP address, Ethernet, protocol DHCP, etc., then you would have heard of some concepts about networking already. So for example, what is this IP address? Things like IP address people use often, but then there are some things that are pretty confusing. For example, there's something called a subnet mask, which we will often see. So so let's go and see here. You look at the connection information, you'll see something like this called a subnet mask. There's something called DNS, broadcast address, IP address, default route, IPv4, IPv6. All these are pretty confusing. And then you look, there are two different IP addresses, 192.168.7239. And then this one is this, well, there's a lot of things going on down here. What is this / number? Yeah, what is hardware address? All of this, can be a bit confusing, can be very intimidating, especially if you're trying to debug some connection between your PC and a device, or your PC and a router. So all in all, it's scary. Okay, so this video is meant for like non-experts, such as myself. I'm not an expert, but I'm learning, and as I learn, as usual, I like to document things down. And the way I like to solidify my learning is just to create videos. So pardon me, I will go very slow. I might not get everything right, but I will attempt to do my best. And of course, I've read out the sources before, and you should be able to find some online. So speaking of sources, I'd like to introduce you to some very good resources. One of them is this computer networking complete course, beginner to advanced, published by Geeks Lesson. It seems to be a very 5-hour long video. I found it very helpful. Of course, there's Wikipedia and some other stuff online. I'm going to talk about something called MAC address. And just for your information, it has nothing to do with Apple or iOS or anything like that. It means something totally different. So there are lots of addresses like this MAC address, IP address. Sometimes can be very confusing, and all these terms are so confusing as well. So let's try to run through from the very basics. Okay, so let's get started proper. 3:15. all right. And of course, I'll paste everything inside the description, so be sure to look out for it. Now, what is networking about? All right, networking is perhaps the art or science of connecting many computers together, making sure they can talk to each other. So you have one computer here, looking like this, okay, and you have this sort of screen here, and you want this computer to talk to another computer. All right. So for example, maybe you have a Facebook message or something like that, or you just want to send a simple signal from computer A to computer B, right? Okay, so this is the most simple way to get computer A to talk to computer B. So what do you do? Okay, so if computer A is like a desktop, and you kind of need to have a physical connection, we will not talk about wireless or anything like that yet. How do you do that? Okay, first thing first, you need to connect a wire, right? You connect some sort of wire to send an electrical signal from A to B and then B to A. Okay, so these wires will usually be copper in nature, twisted copper wire. It's very similar to some electrical cabling that you will find at home. Okay, so this is twisted copper wire that enables computer A to send electrical signals to computer B. So let's say how are the signals being sent? So if you think of this voltage versus time graph, so let's say let's say you have 0 volts and 5 volts, right? 0 volts and 5 volts. So how computer A can send a signal such that 5 volts is interpreted as a 1 and 0 volts is interpreted as a 0. So a 1 and 0 can look something like that. 1 and 0. Okay, and then maybe if it goes, you can increase the voltage to 5 volts again, and you will sort of interpret it as 1. So you'll have these voltage signals, and I guess you can have a machine here that interprets the zeros and ones, converts it into voltage signals, and then a receiver here will sort of look at these voltage signals and produce a string of zeros and ones for computer B to read. So these are like the very basics of how computer A can talk to computer B. So so let's say there is some noise, right? Okay, the nice thing about this is that it's a digital signal, means the signal is only 1 or 0. So that means if the voltage is not perfectly for 5 volts, maybe it's 4.8 volts, right? 4.8 volts is maybe over there it will happen because of some noise or some other thing that happens. Okay, so how this interpreter can read this 4.8 volt signal? Well, because 4.8 volt is so close to 5, it can still interpret the 4.8 volt as 1. So this is what digital signals are about. Okay, digital signals, and the advantage is it's that it's a little bit more resistant to noise. So like, for example, signals of 4.8 volts can be interpreted as a 1, and 0.2 volts can be interpreted as a 0 volt or a 0 signal. Alright, so these are basics about digital signals and why they are important, because they are resistant to noise. So let me delete this too, and yeah, let's go to the next part. Okay, so well, let's say you only have one wire for computer A to talk to computer B, right? For computer A to talk to computer B. Again, we'll have our voltage versus time graph across one wire only. Okay, so again, if computer A sends the signal for it to be 5 volts to be 1, 0 volts to be 0, because the computer will read ones and zeros, right? These are called bits, data bits, but come more on that later. Yeah, let's see. Yeah, so this will be read 101. Okay. Now the thing is that if computer A is sending this 5 volt signal, can computer B use this same cable to pass the 5 volt signal over this way? All right. Answer is no. It's difficult, because if this whole cable is set to 5 volts and computer B tries to put a 5 volt signal in, so if both computer A and computer B are sending the same signal across the same wire, then you will have something like interference, right? Interference. Okay, so what happens will be that computer A's signal will overlap with computer B's signal, and this will be something called a data collision. Okay, data collision. Alright, so that's, I guess, the technical term. Data collision. Okay, so as with most wires, there are only one-way streets, so that computer A can only send a signal to computer B at one time, or computer B can only send a signal to computer A at one time. Okay, so this is what we call data collision, when those signals kind of interfere with each other. So when computer A is talking, computer B must listen, and when computer B is talking, computer A must listen. So that is what I guess we like to call, yeah, that's not what we like to call, well, they call this simplex, duplex, and half duplex and full duplex. Okay, so that's going to tie us into this next topic called simplex, half duplex, and duplex. So ideally speaking, for this wire, we'll have computer A doing transmission. Okay, computer A will only do transmission, computer B will only do receiving. Okay, across this particular wire. Okay, when you have a unidirection, one direction transmission, and one direction receiving. So computer A talk to computer B only. So this wire is only for computer A to talk to computer B, no other way. We like to call this, okay? We like to call this, this is called simplex. Simplex transmission, okay? Simplex transmission mode, okay? So you can look for this in Geeks for Geeks. Again, I'll paste the sources there. Simplex transmission. Okay, so simplex is only one way, okay? This is just one way communication. All right, one way. So this is one way. Now, just now I described a situation where maybe you can use the same wires on the road. Same wires, not, yeah, let me delete layer. Okay, so just now I was saying that depending on how you configure your wire, so you can actually use the same wire as if it's a one lane road. You can use the same wire to transmit and receive. However, when computer A is talking, computer B must listen, and when computer B is talking, computer A must listen. So this is a two-way thing, okay? It's two-way traffic, but you can imagine a one lane road. You can imagine this like a one lane road. And what happens is that when the car is going this way, from computer A to B, when going from A to B, you must make sure the road is completely clear. And only if and only if the road is clear, then B can send a car back to A. So this mode of transmission, yes, it is two-way, but you kind of got to check whether the other computer is sending a signal first. This is what we like to call half duplex. Right? Duplex basically means it's a two-way communication or two-way transmission and receiving. Two-way transmission and receive. But okay, let me delete all this. Yeah. So this is called half duplex, where we can transmit and receive along the same cable. However, the only issue here is that, hey, I will need to wait, right? I need to wait for the other computer to stop talking, then I start to talk. So this is called half duplex. So for a two-computer system, that is okay, but as you add more and more computers to try and get them to talk to each other, you will have an issue. So what is a better way, right? It seems that a better way is just to connect one more piece of wire in the same way here, so that one wire can go this way from A to B, and one wire can go this way. Now these two wires so-called combined together, it will form a full duplex cable, because now computer A can talk to B, and computer B can listen, and computer B can transmit at the same time. So this is the second cable, which can be a dedicated cable for B to transmit signals to A, and the first cable can be a way for A to transmit signals to B without interference with each other. Okay, so this is called full duplex. Okay, full duplex communication. All right, so these are the basic terminologies you might come across every now and then. So next question. Okay, next question is this. Well, we want to have two cables, right? We want to have two cables so that the signal in one cable doesn't interfere with the other cable, right? So that is the ideal. That's why we have two cables. Now, the little bit of a tricky part is this: when electrical signals are sent from A to B, all right, when they are sent from A to B, and then they have this alternating voltage and different changing current, this will actually create a magnetic field. Okay, this will actually create a magnetic field, and this magnetic field, which is changing, will then induce some current inside the other wire. So ultimately, to have 100% zero interference, that is impossible. the way around it is to so-called make better wires. I'm not going to talk about that, but this phenomenon of interference is called crosstalk, because one wire seems to talk to the other, and this will actually add to the noise. So the thing is that you don't want too many wires to be bundled together, okay? So so as to minimize this crosstalk phenomena. Of course, there are other ways of minimizing crosstalk, but I won't be covering them. Okay, so again, the source you can actually look here. Wikipedia is one. This one is from NSYS, I guess. Okay, electromagnetic crosstalk is interference caused by electromagnetic signals affecting another electromagnetic signal. Okay, of course, the best way to avoid crosstalk altogether is to use fiber optics, because this will minimize any kind of electromagnetic field being transmitted from one fiber optic cable to another. But of course, it's a more brittle and expensive solution. But that is what crosstalk is about. Alright, so yeah, this is a so-called crash course for signals and how to get one computer to talk to the other. Okay, so yeah. So now let me just delete everything, and I want to go to another topic. So we have just covered how one computer can start talking to another. So let me draw two PCs again. Alright, 1 2 3 4 1. Okay, two PCs. Alright, we've covered all the ways one PC can talk to the other, and ideally we use something called a full duplex transmission, a cable that is capable of full duplex transmission. So one computer can talk to the other, and they can send and receive signals at the same time. Okay, so now we don't only want to connect one computer to the other thing at home. We actually want to connect more and more computers. So you know, the internet is like literally millions of computers, billions of I don't know whether it's billions yet, but if there are at least 1 billion cell phones, that's 1 billion computers talking to each other. So how do we go from 2 computers talking to each other to maybe 1 computer talking to 5 computers at home? So so now we have this problem of scale up, right? So we don't just have 1 computer talking to 1 computer. We have 1 computer maybe now talking to maybe another 4 computers, right? So let me draw again the computers. Okay, so maybe I'll call them A, B, C, D, E or something like that. Yeah. Oopsie. Alright, then let me get this. Alright, so let's call this computer A, computer B, computer C, computer D, and computer E. Alright, so now we want to get them to talk to each other. And let's say we just let me delete this and delete this. Delete this fella. Okay, let's say we do a very crude method, right? Okay, so I'm just going to hook the wire A to B. I'm going to hook a wire there, and let's just have everything hooked together using wires. So you can imagine there'll be a little bit of a problem. Okay, and of course we want to protect these wire casings, make sure it's able to connect, and of course you don't just want to twist all these copper wires and then have them bunch together. Maybe you have some device that helps you connect these wires together. Okay, you have some device that actually helps you connect all these wires together so that you don't have to twist the wires together yourself or do it manually. You can plug them into an interface. So this is what we will call a hub. Okay, and this is the simplest way to do it. Okay, so again, you might have your duplex cables and all. However, the problem with this version of computers talking to each other is this: if A sends a signal to the hub, Okay, if it sends a signal here, a voltage signal, okay, B will receive it, E will receive it, D will receive it, and C will receive it. Okay, so and the thing is that since you don't want to have individual cables from A to C, A to D, A to E, A to B, all of them. You don't want to have individual signals, so you kind of operate in a half duplex kind of mode where, well, it's not exactly half duplex, but it's similar in concept, I think. So that if A is sending out signals, B, C, D, and E got to keep quiet. Okay. Likewise, if B sends signals to the hub, and A will receive it, C will receive it, D will receive it, E will receive it, then every other computer has to keep quiet and listen. So this is how I guess networking sort of started as a concept. They communicate all these wire through a hub. Okay, so the hub is where it's very similar to just now, the two-wire concept. Yeah, the hub is very similar in concept to the hub is similar in concept to the wire connection in the fact that there's nothing really filtering out the signals, nothing really there's no shortage. If A sends a signal out to the hub, B, C, D, and E will receive it, and it will be the same for each of them. So only one computer can talk at a time. Okay, so this is in terms of at least visualizing it conceptually, it is simple to grasp the concept. How this is done is a bit more complex. So is there any way we can improve upon this method? Because ideally the goal is this. Okay, the goal is this. All computers can talk to each other. Okay, all computers can talk to each other more or less at the same time. Okay, goal, all computers can talk and listen to each other at the same time. Okay, without causing interference. This is the goal of what we are doing right here. Okay, let me do this. Okay, you get the point. I'm not going to So the goal of it is to have all the computers able to talk to each other, and they can transmit and receive signals individually without jamming up the whole information highway. So how do we do that? Okay, so we have to move one step up. You have to do some sort of traffic control at the hub. Okay, traffic control, so to speak. Okay, I'm not using the professional names or whatever, but I'm just trying to get the concept across that the hub is there and you need to do some traffic control with it. So let's just assume for the sake of argument that you already have your traffic control on the hub, such that when A talks and when A tries to transmit a signal intended for computer D, it will only go to computer D. Computer C, computer E, and computer B will not receive or send any signals. Okay, what is this system called? Okay, this system is no longer called a hub. Well, it used to be called a special kind of hub, but we will just call this thing a switch. Okay, and if you take a look at switches nowadays, these are switches which you can, I guess, get from Best Buy. This is here to help you. You call it Ethernet switch. Ethernet is is very closely related concept for this. So what you have, instead of a hub and you just connect wires to the hub, you have a switch, and you kind of connect all your Ethernet cables into the switch. Okay, so this device here is called a switch, which I guess you can find at home, you can find at Best Buy. So we don't really use the hub anymore. Okay, at least the video I saw online told me it wasn't the case. It's very rare now to have a hub. Okay, very rare now to have a hub connecting computers, at least in this scale. So instead, what you do is that you have a switch so that you can connect A to the switch, B to the switch using Ethernet cable, C, D, and E to this Ethernet cable. And then what this switch will do is to decipher the signal from A, and based on the signal from A, you should be able to have information like they're sending mail. Maybe they're sending like electronic mail, so to speak. Okay, so they're sending electronic mail into the hub, and this envelope has an address. Okay, I'm going from computer A, and I'm shifting it. I want this information to go to computer D. Okay, so all of this kind of falls under the category of Ethernet. Okay, Ethernet is not just plugging one computer into another. Okay, as you saw in the hub, it is a way of connecting one computer to several computers in the so-called local area connection or local area network. We call it LAN. So it's a local area network, LAN. So it enables the computers to talk to each other without jamming up the whole highway, because we have this thing called the traffic control. Okay, so all this will fall on how this is done, how the traffic is managed. That will fall under the Ethernet category, and that's one of the most common technologies which we use today. So I guess I'll stop here because that's a fair bit of concepts covered. So I hope I didn't get any of it wrong based on the learning I just did today. But yeah, I will post these sources down, some examples of switches and hubs, what is crosstalk and what is a digital signal. Okay, so these are basics of networking for non-networking people like myself. So hope you found this video useful. Thanks.